The National Electrical Code does not permit the hardwiring of a hairdryer to a ground fault circuit interrupter device or any other receptacle. National Electrical Code Section 406.3e states that hairdryers shall not be cord connected and shall be permanently connected. National Electrical Code Section 410.11 states that receptacles installed in bathrooms shall have ground fault circuit interrupter protection. The National Electrical Code requires hairdryers to be permanently connected to prevent the risk of electric shock. Hardwiring the hairdryer to a ground fault circuit interrupter device does not meet this requirement because the ground fault circuit interrupter device can be reset, allowing power to flow to the hairdryer even if the connection is faulty. The only acceptable options are firstly, replace the hardwired hairdryer with a cord input model, or secondly, replace the circuit breaker feeding the receptacle with a ground fault circuit interrupter breaker. This will provide ground fault circuit interrupter protection while maintaining the permanent connection for the hairdryer. It is strongly recommended that the circuit breaker feeding the receptacle be replaced with a ground fault circuit interrupter breaker to ensure compliance with the National Electrical Code and provide maximum safety. This option will also eliminate the need for maintenance in the event of a trip. When dealing with electrical installations, it is crucial to adhere to the National Electrical Code, or NEC, to ensure safety and prevent electrical hazards. This specific situation involves a hardwired hairdryer and its compatibility with ground fault circuit interrupters, or GFCIs, in a bathroom setting. The NEC has specific requirements for electrical installations in bathrooms, particularly concerning hairdryers and GFCI protection. Understanding these requirements is essential for compliance and safety. The NEC mandates that hairdryers should be permanently connected, as stated in NEC Section 406.3e. This requirement aims to prevent the risk of electric shock by ensuring a secure and stable connection. The code also stipulates in NEC Section 410.11 that all receptacles installed in bathrooms must have GFCI protection. GFCIs are designed to detect ground faults and quickly interrupt the circuit, minimizing the risk of electrical shock in wet environments like bathrooms. Given these NEC requirements, hardwiring a hairdryer directly to a GFCI device or a standard receptacle is not permissible. The rationale behind this prohibition is that hardwiring to a GFCI device does not guarantee a permanent connection as required by the NEC. A GFCI device can be reset, potentially allowing power to flow to the hairdryer even if there is a fault in the connection, thereby defeating the safety purpose of the permanent connection requirement. Considering the NEC guidelines, there are two acceptable options to address the situation. First option is to replace the existing hardwired hairdryer with a cord and plug model that can be plugged into a GFCI protected receptacle. This approach ensures compliance with both the permanent connection requirement and the GFCI protection requirement. The second option involves replacing the circuit breaker that feeds the bathroom receptacle with a GFCI breaker. This solution provides GFCI protection for the entire circuit, including the hardwired hairdryer, while maintaining the required permanent connection. Choosing between these options depends on various factors, including cost, convenience, and the specific needs of the installation. However, replacing the circuit breaker with a GFCI breaker is generally recommended as it offers comprehensive protection and eliminates the need to modify the hairdryer itself. In summary, the NEC prohibits hardwiring a hairdryer directly to a GFCI device or a standard receptacle. To ensure compliance and safety, either replace the hairdryer with a cord and plug model or replace the circuit breaker with a GFCI breaker. Always consult with a qualified electrician to determine the best solution for your specific situation and to ensure that all electrical work is performed in accordance with the NEC and local codes. Ground fault circuit interrupters, or GFCIs, are essential safety devices that protect people from electrical shock. They work by monitoring the current flowing in a circuit and quickly interrupting the power if they detect a ground fault. A ground fault occurs when electricity strays from its intended path and flows through an unintended conductor, such as a person's body. GFCIs are designed to detect even small ground faults and trip the circuit in a fraction of a second, preventing serious injury or death. GFCIs are commonly found in bathrooms, kitchens, and outdoor areas where there is a higher risk of exposure to water and moisture. The NEC requires GFCI protection in these locations to minimize the risk of electrical shock. In bathrooms, GFCIs are required for all receptacles, including those that serve countertop appliances and hair dryers. The NEC also requires GFCI protection for other electrical equipment in bathrooms, such as lighting fixtures and exhaust fans. When selecting a GFCI device, it is important to choose one that is listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. UL listing indicates that the device has been tested and meets safety standards. There are two main types of GFCI devices: receptacles and circuit breakers. GFCI receptacles are installed in place of standard receptacles and provide GFCI protection at the point of use. GFCI circuit breakers are installed in the electrical panel and provide GFCI protection for the entire circuit. When installing a GFCI device, it is important to follow the manufacturer's instructions carefully. Incorrect installation can render the device ineffective and increase the risk of electrical shock. It is also important to test GFCI devices regularly to ensure that they are working properly. GFCIs have a test button that can be used to simulate a ground fault and verify that the device trips as intended. If a GFCI fails to trip when tested, it should be replaced immediately. In addition to GFCIs, arc fault circuit interrupters, or SIs, are another type of safety device that can help prevent electrical fires. SIs are designed to detect arc faults, which are dangerous electrical arcs that can occur in damaged or deteriorated wiring. Arc faults are a leading cause of electrical fires in homes. SIs work by monitoring the electrical current for patterns that indicate an arc fault. When an arc fault is detected, the SI trips the circuit, interrupting the power and preventing a fire. The NEC requires SI protection for many circuits in homes, including those that serve bedrooms, living rooms, and dining rooms. SIs are typically installed in the electrical panel as circuit breakers. Like GFCIs, it is important to test SIs regularly to ensure that they are working properly. SIs also have a test button that can be used to simulate an arc fault and verify that the device trips as intended. If an SI fails to trip when tested, it should be replaced immediately. Both GFCIs and SIs are important safety devices that can help protect people from electrical shock and prevent electrical fires. By understanding how these devices work and installing them correctly, one can create a safer electrical environment in one's home or workplace. Electrical safety is a critical aspect of any building's infrastructure. Ensuring that electrical systems are installed and maintained according to the National Electrical Code, or NEC, and other applicable standards is paramount for protecting occupants from electrical hazards. One common area of concern is the proper wiring and protection of electrical appliances, particularly in locations like bathrooms where the risk of electric shock is high due to the presence of water. Hairdryers are a common appliance found in bathrooms, and their electrical connection must comply with specific NEC requirements to ensure safety. As previously mentioned, the NEC mandates that hairdryers be permanently connected, meaning they should not be cord connected. This requirement aims to prevent the risk of electric shock by ensuring a secure and stable connection that is less prone to damage or accidental disconnection. The NEC also requires ground fault circuit interrupter protection for all receptacles in bathrooms. GFCIs are designed to detect ground faults, which occur when electricity strays from its intended path and flows through an unintended conductor, such as a person's body. GFCIs quickly interrupt the circuit when a ground fault is detected, minimizing the risk of electrical shock. When considering the installation of a hardwired hairdryer in a bathroom, it is important to understand that directly connecting it to a GFCI device or a standard receptacle is not permissible under the NEC. The GFCI device is intended to protect the receptacle and any cord-connected appliances plugged into it, not to serve as the primary connection point for a hardwired appliance. To comply with the NEC, one must either replace the hardwired hairdryer with a cord and plug model that can be plugged into a GFCI protected receptacle, or replace the circuit breaker that feeds the bathroom receptacle with a GFCI breaker. Replacing the circuit breaker with a GFCI breaker provides GFCI protection for the entire circuit, including the hardwired hairdryer, while maintaining the required permanent connection. This option is often preferred as it offers comprehensive protection and eliminates the need to modify the hairdryer itself. In addition to these specific requirements, it is also important to ensure that all electrical work is performed by a qualified electrician who is familiar with the NEC and local codes. Proper wiring techniques, grounding, and overcurrent protection are essential for ensuring the safety and reliability of the electrical system. Regular inspections and maintenance are also important for identifying and addressing any potential electrical hazards before they can cause harm. By adhering to the NEC and following best practices for electrical safety, one can create a safe and reliable electrical environment for all building occupants. The importance of safety in electrical installations cannot be overstated. Electrical systems are complex and can be dangerous if not properly installed and maintained. The National Electrical Code, or NEC, provides a comprehensive set of standards and guidelines for electrical installations, and it is essential for electricians and other qualified professionals to adhere to these requirements to ensure the safety of building occupants. One of the key aspects of electrical safety is proper grounding. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protection devices such as circuit breakers to trip and de-energize the circuit. Without proper grounding, fault current can flow through unintended conductors, such as metal enclosures or even a person's body, creating a serious risk of electric shock. The NEC specifies detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the methods for connecting grounding electrodes, and the bonding of metal enclosures and equipment. These requirements are designed to ensure that the grounding system is effective in providing a low impedance path for fault current. Overcurrent protection is another critical aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Overloads occur when too much current flows through a circuit, causing the wires to overheat and potentially start a fire. Short circuits occur when there is a direct connection between two conductors, resulting in a large and rapid flow of current that can damage equipment and cause a fire. The NEC specifies the types and sizes of overcurrent protection devices that must be used for different types of circuits and equipment. It also requires that overcurrent protection devices be properly coordinated to ensure that they trip in a selective manner, minimizing the extent of the outage in the event of a fault. In addition to grounding and overcurrent protection, there are many other aspects of electrical safety that must be considered. These include proper wiring techniques, insulation and clearances, the use of approved electrical equipment and materials, and the installation of safety devices such as ground fault circuit interrupters and arc fault circuit interrupters. Electrical safety is not just the responsibility of electricians and other qualified professionals. Building owners and occupants also have a role to play in ensuring electrical safety. This includes reporting any electrical hazards to the appropriate authorities, avoiding overloading electrical circuits, and using electrical equipment and appliances safely and responsibly. By working together to promote electrical safety, we can create a safer environment for all. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years to reflect the latest advances in technology and safety practices. The NEC is widely adopted by state and local jurisdictions throughout the United States and is considered the benchmark for electrical safety. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, equipment installation, and special occupancies. It provides detailed requirements for electrical installations in residential, commercial, and industrial buildings, as well as outdoor areas. The NEC is organized into chapters, articles, and sections, each addressing a specific aspect of electrical installations. The chapters cover broad topics such as general requirements, wiring and protection, wiring methods and materials, equipment for general use, special occupancies, special equipment, and communications systems. The articles provide more specific requirements within each chapter, and the sections provide detailed instructions for complying with the article requirements. The NEC is not a design manual, but rather a set of minimum safety requirements. It is the responsibility of qualified electrical professionals to design electrical systems that meet the NEC requirements and are also appropriate for the specific application. The NEC is constantly evolving to keep pace with new technologies and changing safety practices. The NFPA solicits input from a wide range of stakeholders, including electrical contractors, engineers, manufacturers, and code officials, to ensure that the NEC remains relevant and effective. The NEC is an essential resource for anyone involved in electrical installations. By understanding and adhering to the NEC requirements, electrical professionals can ensure the safety and reliability of electrical systems and protect building occupants from electrical hazards. Electrical safety inspections are an important part of maintaining a safe electrical environment. Regular inspections can help identify potential electrical hazards before they cause harm. Electrical inspections are typically performed by qualified electrical inspectors who are trained to identify code violations and other safety issues. The scope of an electrical inspection can vary depending on the type of building and the purpose of the inspection. In general, electrical inspections include a visual examination of the electrical system, including wiring, panels, receptacles, and lighting fixtures. The inspector will also test certain components to ensure that they are functioning properly. During an electrical inspection, the inspector will look for a variety of potential hazards, including damaged or deteriorated wiring, overloaded circuits, improper grounding, and missing or damaged safety devices. The inspector will also check to ensure that the electrical system complies with the NEC and other applicable codes. If the inspector finds any code violations or other safety issues, they will typically issue a report outlining the findings and recommending corrective actions. It is the responsibility of the building owner to correct any deficiencies identified in the inspection report. Electrical inspections are often required as part of a real estate transaction or when applying for a building permit. They may also be required by insurance companies or other regulatory agencies. In addition to formal electrical inspections, it is also important to perform regular self-inspections to identify any potential electrical hazards. This can include checking for frayed or damaged cords, loose receptacles, and overloaded circuits. If you notice any potential electrical hazards, it is important to contact a qualified electrician to have them corrected. Electrical safety is a shared responsibility. By performing regular inspections and taking corrective actions when necessary, we can create a safer electrical environment for all. Choosing a qualified electrician is an important step in ensuring the safety and reliability of electrical work. A qualified electrician has the knowledge, skills, and experience necessary to perform electrical installations and repairs in accordance with the NEC and other applicable codes. When choosing an electrician, it is important to consider their qualifications, experience, and reputation. You should also check to see if they are licensed and insured. To find a qualified electrician, you can ask for referrals from friends, family, or neighbors. You can also search online directories or contact your local electrical contractors association. Once you have identified a few potential electricians, it is important to interview them and ask them about their qualifications, experience, and insurance coverage. You should also ask for references from past clients. When interviewing electricians, it is important to ask specific questions about the type of work you need done. This will help you determine if they have the necessary experience and expertise. You should also ask for a written estimate of the cost of the work. Before hiring an electrician, it is important to check their license and insurance coverage. You can typically verify an electrician's license online through your state's licensing board. You should also ask for proof of insurance coverage, including both liability insurance and workers' compensation insurance. Once you have chosen a qualified electrician, it is important to have a written contract that outlines the scope of the work, the cost of the work, and the payment schedule. The contract should also include a warranty for the work performed. By taking the time to choose a qualified electrician and having a written contract, you can help ensure that the electrical work is done safely and properly.